Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. This is the lecture number 4 of testing of hypothesis. In this lecture, I will discuss one very important example of binomial, which is normal approximation to binomial distribution, which we used to do in S1. An important advice, we should be nice to everyone. This question is from June 21, paper 6 2, question 1. In a game, a ball is thrown and lands in one of 4 slots labeled A, B, C, and D. Raju wishes to test whether the probability that the ball will land in slot A is 1 upon 4 or not. This is a two-tailed test. He wishes to test whether this probability is 1 upon 4 or not. So H naught, the probability is 1 upon 4, and H1, the probability is not equal to 1 upon 4. This was part A. State the null hypothesis and alternative hypothesis. The ball is thrown 100 times. Because of this 100, very large n, we use normal approximation to binomial. Because for normal approximation to binomial, remember the hint was n is large, greater than 30. And the condition was np greater than 5 and nq is also greater than 5. So this is binomial with n 100 and p is 1 upon 4. So np is 25, whereas npq is 75 upon 4. And this is the test value, x. And we have to perform the test at 2% significance level. Since this is a two-tailed test, therefore we have to check 2%, we have to divide 2% equally, like 1% here, 1% here, because of a two-tailed test. Now we need the corresponding value of z. Let me check the value of z. It's 2.326, and this is minus 2.326. Okay, how will you find this value? This is very simple. See, this is 1%. So this total is 99%. Just check 99% either in your calculator or in normal distribution table and get this value. Now we have to check whether this test value is greater than mean or less than mean. Before checking that, we just need to write normal approximation. So here we write np, here we write npq. So x is normal, np is 25, this is 75 upon 4. Now we have to observe whether test value is greater or less than mean. So test value. In two-tailed test, you have to check this. The test value is 15 and the mean is 25. Since 15 is less than 25, therefore you have to perform the lower tail test, this test. In two-tailed test, remember, always compare test value with the mean. If the test value is less than mean, then perform this test. If the test value is greater than mean, let's suppose the test value was 30, let's suppose, which is greater than 25. So perform this test. So perform the lower tail test. This is very important because you have to do continuity correction. So we need this probability, x less than equal to 15. In a lower tail test, we always have lesser sign here, and test value is always inclusive. Now check continuity correction on number line. So this is 15, this is inclusive, you have to go here. So whenever we go on left side, we take upper bound. So this is 15.5. So we have to write this statement in the form of z. Less than equal to 15.5. 15.5 minus mean, which is 25. minus mean, which is 25, divided by under root 75.4. So we need this probability. Well, this number is, you have two options, either find probability or find value of z. The best way is find value of z. I mean, just do this. I'm writing both the options. If you want to find probability, then do this. And if you do not want to find probability, then just write z. When I will explain normal distribution in testing, then you will easily get this concept. Well, your answer is minus 2.194. This is z test. See, either find this or find this. I always find this because this is very simple to compare. And this is known as z test. Now you have to check whether this value lies in critical region or not. Minus 2.194. See, minus 2.194 is here. It's not in critical region. This is here. As minus 2.194 is greater than minus 2.326, or we can say that is minus 2.194 is not in critical region, therefore accept H naught. Insufficient evidence to accept Raju's claim. Evidence to conclude or to say that P is less than 1/4. P is not equal to 1/4. Because we accept H naught. When we accept H naught, then we reject this fact. Insufficient evidence to say that P is not equal to 1/4. So this is the example question of normal approximation to binomial. Here the most important part was continuity correction, and for that you had to compare test value with this mean. If the test value is less than this in two-tailed test, then you have to perform the lower tail test. So you have to take the upper bound of 15. Get the z test and then compare z test with the critical value, z critical. This is known as z critical. Since this value does not lie here, so that means accept H naught and reject P not equal to 1/4. Hope this lecture will help you to understand this concept, normal approximation to binomial. You can get the soft copy of this lecture from the math website and check the link of the math website in the description. Good luck. Allah Hafiz.